Hello and welcome to my channel. If you have not subscribed, please do so. Today's class will amaze you, I'm telling you. So we have been dealing with integration for a while. And today we want to deal with trigonometric substitution. Now, under trigonometric substitution, we have these three basic or major to say substitution, where you have a function of this form. Your substitution for x is a sin theta, that of this form is a tan theta, and this is what? A sec theta. Now we'll be using this to solve this. We say evaluate the integral of the root of 4 minus x squared over x squared dx. So how do we solve this? We solve this using the first formula given to us. Now, watch. I say note. Here, you can see we say that x from here should be a sin theta, where a is the constant. So it means that a in this case is what? 4. So we say that a squared is equal to what? 4. So what do? We take roots of both sides. If we take roots of both sides, this cancels this. The root of 4 is what? 2. So this implies that a is equal to what? 2. So from this point, we know that a is what? 2. Then again, we want to check for x. So we now write that x is equal to, instead of a, we put what? 2. 2 sin theta. Okay? So we differentiate x with respect to what? Theta. So the x, the theta, is equal to, for this, 2 cos theta, 2 cos theta. Okay? So if we cross multiply to make the x the subject, so it means the x is going to be 2 cos theta d theta. So this becomes our substitute for the x. Okay? Now back here, we say this is equal to integral. Now instead of this, we are writing 4, the root of 4, minus, what is x? X is 2 sin theta. So this is going to give us 2 sin theta, all squared. Now, what is the x? This is over x squared. Since this is x squared, we still replace with this. We have 2 sin theta, all squared. Instead of the x, we say that the x is what? 2 cos theta d theta. So this is dot cos 2 cos theta d theta. Okay? So we are done with our substitution now. So now what do? We can open these brackets. So we say this is equal to the integral of the square root of 4 minus 4 sin square theta, all over 4 sin square theta. Because if we take the square in, we are going to have sin squared, and this 2 becomes 4 since it's 2 times 2. So we now have dot 2 cos theta d theta. The dot simply means multiplication. So now we proceed with our integration. Now, this is 2, this is 4, so we can reduce this. If we cancel 2 here is what? 2. And also, we can shift out 4, since 4 is common. So this is going to give us integral, the square root of, instead of 4 minus 4, we have 4 into 1 minus sin square theta.
So it's still the same thing as this. All over, remember we've cancelled this, so we are left with what? 2 sin square theta cos theta d theta. So this is very simple, just follow me. So at this point, what else do we do? Also recall that sin square theta plus cos square theta is equal to 1. I think we handled this in our last class, or in our last 2 classes. So if we make cos square theta the subject, it means we are taking sine this way and it becomes minus. So this will give us cos square theta equals 1 minus sin theta. So this can represent this and vice versa. So on this equation we have this. So we can replace this with this. Okay? So we're going to do that. So this is going to give us integral of the root of 4 cos square theta all over sin square theta cos theta d theta. Okay? So now at this point we can take root of what we have here. So this is going to give us the integral. The root of 4 is 2, and the root of cos square will give us only cos theta all over sin square theta cos theta d theta. Okay? So at this point, okay, we also have 2 here, sorry, from here. So this cancels this. We now have the integral of cos theta over sin square theta cos theta d theta. This will multiply the numerator for us to get the integral of cos theta square, cos square theta sin square theta d theta. So at this point, I'm going to resubstitute for this here. Since we know that cos square theta is 1 minus sin theta and 1 minus sin theta is cos square theta, I want to return this to this point. So this now becomes the integral of 1 minus sin square theta all over sin square theta d theta. So we can separate this to give us 1 over sin square theta minus sin square theta over sin square theta d theta. Okay? So this is an identity which will give us cosec theta, give us cosec square theta minus, this is sin square theta over sin square theta. So it's the same thing as 1, because if we divide it by this, we get 1. So we now have the theta. So if we integrate this, we will be getting minus cot theta. If we integrate a constant, we get a variable which is theta plus c. But now the big question is, can we leave our answer this way, knowing that our question is a variable of x? So our answer cannot remain as a variable of what? Theta. So what do? We try to reintroduce what? Our x. So how do we do that? Recall from here that x is equal to what? 2 sin theta. So if we make sin theta the subject, we'll be dividing here by 2 and here by 2. So this cancels out. It means sinθ is equal to x over 2. So if sinθ is equal to x over 2, it doesn't solve our problem. So we expand further in our knowledge. How? We check using the trigonometric ratio, which we know as cosθ. So knowing that sinθ is equal to x over 2 means sinθ is equal to opposite over what? Hypotenuse. That's what this means, opposite over hypotenuse. So it means x is opposite and 2 is our hypotenuse. So if you allow me, let me draw a right angle triangle, and this is our angle theta. So this becomes the opposite, which is x, and this is the hypotenuse 2. So we don't have the adjacent. Now, what am I even trying to do in the first place? I'm trying to look for an identity in such a way that will get cos theta. So sine has nothing to do with theta. So we need this to get tan. So how do we get tan? Since we have these two, we know that by Pythagoras theorem that c squared is equal to a squared plus what? B squared. And in Pythagoras theorem, c squared is the longest side, which is 2. So we quickly substitute 2 squared equals to the opposite, which is x squared, plus the adjacent remains b squared because it's unknown. Then we try to make this the subject by taking this way. This is 2 squared becomes 4. So if we take this way, it becomes minus x squared equals to b squared. So what do? We say take roots of both sides. So we are taking root of both sides. So this becomes the root of 4 minus x squared equals to the root of b squared. So this cancels this. It means that root 4 minus x squared is equal to what? B. So we found this point, which is b. So we can redraw this to be root 4 minus x squared, and here is our x, and here is what? 2. So we've gotten all of this. So now, with all of this, we can find tan. What is tan? Tan is tan theta is equal to what? Opposite over what? Adjacent. Opposite is x over adjacent, which is the root of 4 minus x squared. Fine. But now, tan is not looking like what we have here, because what we want to do is this. So how do we solve this? Well, we know that cot is the reciprocal of tan. That is, cot is equal to 1 over tan. So thank God we are here now. So how do we do this? We simply say that cot is equal to 1 over tan, which is x over root 4 minus x squared. So this is the same thing as saying 1 divided by x all over root 4 minus x squared. So if this is the case, cot is equal to, we change this to multiplication according to our rule in indices, then this will reciprocate to give us root of 4 minus x squared over x. Of course, if you multiply 1 by this, you still have this. So this implies that cot is equal to what? The root, or maybe you can see from there. Let's use this side. So from here, you can see that cot is equal to the root of 4 minus x squared over x. So we've gotten cot. Now what is theta? Still from here, we say that sin theta is equal to what? X over 2. So what do we do? To get theta means we look for the sine inverse of theta, of sin theta, which is sine inverse of x over 2. So if we do that, sine cancels out sine, means theta is equal to the sine inverse of x over 2. Therefore, our integration becomes minus cos, which is what? The root of 4 minus x squared over x minus theta, which is what? Sine inverse of x over 2 plus c. This is our answer for this question. So if you find this video interesting and educating, I want you to subscribe and share the video, like and drop your comments. If you have any challenge, you can drop it on the comment section. We won't hesitate to come to your aid. Thank you and bye-bye.